Taylorg Swifty Wooferson. The Taylorg was really strange. I don't know what that means. Anyone have any ideas? I don't, what is Taylorg? Maybe the G is for dog? And they thought it sounds, I don't know. Get to work on that if any of you are interested in careers in AI. You can do better. I said after this, I don't like that one, give me 10 more. And it gave me 10 more, and they were all similarly stupid. And none of them were actually like real Taylor Swift references. They just had versions of her name in it. But, yeah. All right. Sorry, Taylor Swift is invading your whole life, even this class. I probably won't say anything else about Taylor Swift. We were talking about regular expressions. Actually, before we get started, I would like to announce our first test is a week from today. And we're not having class next week on Tuesday because it's one of those Monday on a Tuesday things. So that means that our next meeting will be the test. It's going to take up the whole class period, although I don't intend for the test to be super long, but we'll take the whole class to do it. Maybe I'll say more about the test in our last 10 minutes today. All right. Anybody have questions? Vague questions about the test? I mean, the format of the test, the questions you should expect to be similar to the quiz questions. No multiple choice or anything like that. Yeah.
Will there be regular expressions on the test?
Maybe a little bit. So we are going to, even though we don't have class on Tuesday, I thought it would be prudent to have a homework assignment about regular expressions due on Tuesday, just based on what we get through today. So probably not very sophisticated. Yeah.
Is there anything proof related or like just essay form like was on this quiz on the test?
I haven't written the questions yet, so I can't answer definitively, but I mean, that question, I think there might be questions like that. Yeah, probably not a like super technical proof of something. Yeah. All right. You don't really have to write an essay, though. I hope nobody wrote a real essay. This is not what I intended. Okay, let's talk some more about regular expressions, which is written like that. Regular expressions. These are, remember, this is another way to specify a language. It doesn't look like a machine, but you can use it to describe a language in the same way as writing a machine. An example of a regular expression would be something like, so here's a very simple one, A, B star, A. The terminology we use, remember, is we say this matches any string, in this case, starting with A, then some number of B's, where this some number means possibly 0, and then AA at the end. So A, B star, AA matches any string that starts with an A and then has some amount of B's, possibly 0 B's, and then AA at the end. Yeah.
Is there any difference to the star than to just like give it an exponent of n and then say n is all real numbers?
That basically means the same thing, but in a regular expression, there is no such thing as an exponent of n. So you write it with a star. Although I would say you could say, for instance, this one here, if you were writing it in set theory, it would be written like this: A, B to the n, AA. Or I think this is exactly what you said. So in this particular example, the star is more or less interchangeable with an exponent. But in more complicated things, like for instance, AA plus B star, this is not very convenient to write using an exponent because, I mean, you can't write AA plus B to the n, because then I will ask you, what do you mean by plus here? And this is not sensible to write. But anyway, what does that mean? This means a string which begins with an A first, and then it has some amount of stuff, each of which can be either a AA or a B. And they can be sort of mixed and matched. It doesn't have to be the same thing over and over again. And this is hard to write in words. It is what I just said, but this matches any string which starts with A, followed by, I will say, any amount, including possibly 0, of stuff made from AA or B. All right. So in general, the operations are plus, which means or. That's why AA plus B inside the parentheses there means these things look like AA or they look like B. And then the star indicates sort of repetition, or maybe it's a little better to say iteration. It means you do this thing over and over again, but it doesn't have to be exactly the same every time. Oops. So AA plus B star means you do this a bunch of times, but you are allowed to say do AA the first time and B the second time, and so on. All right, these are the basic ideas. Last time I was showing you some sort of real-life regular expressions. People use regular expressions all the time in basic programming with strings, and I thought I wanted to show a little bit more. I thought it might be fun to do some more cute examples involving that. One moment, please. Can you see my... I set this all up before. Sorry. What? That's not what I wanted. Okay. Here we are. So this is my terminal, and you can do regular expressions from the terminal very easily on a Mac or Unix system. The command to use is called egrep, and then I can do something like I don't know, B-O star M. And then, as I said last time, I have a giant file that's just full of 10,000 English words, and one word per line, and they're all lowercase. And what this terminal command is going to do is it searches through the entire file, and every line which matches the regular expression gets printed on the line. So it's going to give me every line. I hope it's big enough for you to see. Every line in my file, that is to say every English word, which has a B followed by some amount of O's followed immediately by an M. So I expect a word like boom to be in there, or kaboom is probably in there. The B doesn't have to be the beginning of the word because it's going to give me any line which matches any part with this regular expression. So I get a lot of things here. I actually don't know if boom is in. Where's boom? Yeah, there's boom. Boomage. We got some boomage in there. I don't see kaboom with a K. I don't know why. We also get something like insubmissive, which doesn't have any O at all, but that's because the star is allowed to do 0 repetitions of the O. And you do have a B followed by M there. All right. There are some simple tricks with regular expressions in real life that are very useful that are not so useful in a theoretical context. But there is a special thing. Oh, I should say, first of all, for reasons, when you're using regular expressions in a typical programming environment, they don't use the plus the way that we use plus for or. They use instead the vertical bar like this. So this one is going to, if I change this to say something like that, this now will match anything that matched before with the boom thing, or anything which has REGG in it, which I don't even know what words have that in it. It's hard to pick out from the rest of it. These ones all match the boom thing. I don't know, does it? Is there a word with reggae should be in there? Yeah, and dreggier, of course. So let's just see if reggae is in here. Yeah, it is right there. All right. So that's in a typical real life regular expression uses the bar, the pipe instead of plus. All right. There's another trick that you can see here is so this gives me anything which has reg in it anywhere. There's a special character which is useful in real life. That caret matches only at the beginning of the line. So this now means it has to be reg occurring at the beginning of the line, and now only reggae matches that. And similarly there's a end of the line one, which is this \r. That's the old carriage return symbol. This, I guess, will match nothing, because this would be a word which actually ends with regg, which nothing happened, which means there were no matches. All right. I thought maybe we could use this, use our great skills here to play the Wordle. I don't know if people still play the Wordle, but just for fun here, I have the. Oh, not that. Sorry. I'm going to use I already did the real Wordle today, but I'm going to use. There's other knockoff Wordle sites where they give you you can just keep on playing it over and over again. So see if I can. Hey, there it is. Oh, that was my practice. I was doing this before class just to make sure it would work. Give me a new one. All right. Anybody got a good first guess? What do you like?
Heart.
Hurt. Okay.
Oh.
Like that?
Yeah.
All right. So I hope you remember, or I hope you know how the Wordle works. There is a secret 5-letter word which we are trying to guess, and you type in. You get 6 guesses total. We're not going to need that many because we're going to cheat with the word list. And the colors here indicate. So the gray one means there is no H at all in this word. The yellow one means there is an A somewhere, but not in this position. And then if you get it correct letter in the correct position, it comes up green. So what we know here is that there's an A and an R. There is no H or E or T. And of course, we also know that the word is 5 letters long. All right. So to use regular expressions to help us out here, I'm going to move over here. I hope you can see. Oh, sorry. I'm doing too fancy here. All right. Maybe I can I put this on top? Okay. One other thing that you can do in regular expressions is there's a special symbol, the dot. So in a real life regular expression, the dot just matches any single character. So if I search in my big list for a string or a regular expression like this, once you're sort of a regular expressions master, you will learn to read nonsensical things like that and understand what they mean. But this means it has to match with the beginning of the line, followed by 5 things, followed by the end of the line, which means any 5-letter word. So if I just do this, I get all of the 5-letter words in there, including zippy. Now, I actually want words which have an A somewhere and also an R somewhere. And there's actually not a very convenient way to do that in this regular expression, because I want to say there's an A, one of these 5 things is an A, but actually that is not something you can really express using the plus and the star. Those are the only operations you can do using regular expressions. But there's one little tricky trick we can do here, and that is I can just run that thing through another grep with a So what this little pipe here, can you see my pointer? Yeah. This little pipe here is going to run the results of this one through another regular expression. So it takes all the 5-letter words, and then from that, I'm only going to get the ones that have an A in them somewhere. And I can also do it again. with only the ones which have a H somewhere. Sorry, I'm off the side.
What's an R?
An R. They do not have a H. All right, thanks. All right, so this is going to give me now only words which have a H. No, whatever I said before. An A and an R, right? There's a lot of them still. Another thing we can weed out is these words should not have a H or a E or a T, right? And we can do that also in some weird regular expression code. These dots, instead of the first dot, I'm going to replace it by this thing, H, E, T. So those square brackets and the caret there means this will now match any character except for these ones which I listed there, H, E, and T. All right, and I can put that actually everywhere. So this is now going to give me things which do not have H, E, T. Unfortunately, there's not really a good abbreviation for all of that. You just have to type it all in. And furthermore, there's actually more information we have, and that is the third letter is not an A. So I can put an A in this one to exclude A's from that position. And then the fourth letter is not an R, so I can put an R there. I think this is as good as we can do now. So it has to be one of these words here. Anybody like any of these ones?
Garbo.
Garbo? Was that one of them?
Yeah.
All right, we'll try that. I don't know if my word list may not be the same as this this Wordle word list. They may not like Garbo. Hey, they like it. All right. I suppose that may be a little disappointing. Now we know the R is in the middle and the A is not in that other position. So that means actually I can take away this guy and just stick the R in the middle position like so, and the A is not in this position. I think that's all the information that we got. So now the list is getting fairly short. Let's try Scrag. There's no G. Oh yeah, we should eliminate those other ones. Yeah, thanks. There was some more information. There's no G, B, or O, so I can put G, B, O inside each of these guys. The order doesn't matter. Isn't this fun? It's going to be so satisfying when we finally win. All right. Scrap? Okay. He's confident. Scrap. Okay, so there's a C somewhere. So then I can put another pipe with a C in it. And there's no C in, there's no S anywhere or P. And there's no C in the second position. Oh, there's my R. Okay. I think we're almost done here. And these are all stupid words. Auric, circa, and curia. Circa? Yeah, I guess. All right. I say getting it in 4 for circa is pretty good. So this has been using regular expressions in real life for fun. This I don't know if this seems like real life to you, but actually, if you just think about trying to write a Python program to do what I just did. Like write a Python program which gives you all 5-letter words which have a R as the middle character, and the first character is not a H, E, T, G, B, O. Like that's very complicated stuff to actually write. I mean, you could write that as a Python code, but you wouldn't want to. Like if you ever find yourself in real life having to do something like that, which that is actually a fairly common operation that you would want to do if you're doing any kind of programming which involves working with strings. If you want to do something like that, you should use regular expressions. And there is if you want to use Python, there's a regular expressions library that you can import into Python and then do all of this kind of stuff using regular expressions. It's super useful. I've had at least one like major programming project that I've been involved in where the whole thing was basically regular expressions, kind of like wrapped inside of a Python program, but basically every line was using some kind of very complicated, fancy regular expressions. It's super useful for a certain type of thing. Any thoughts about that? All right, great. I think I'm done with the Wordles. Okay, let's continue. So I want to do some more sort of abstract examples with the regular expressions. Okay, let's just see, the typical question when it comes to regular expressions is like, I describe a language and then you make a regular expression to give me that language, or the other way around, I show you a regular expression and you tell me what the language is. Let's try, I will just write down a language. And then your job is to make a regular expression for the language. We'll start off easy. A to the n, BA, where n is the integer, or a natural number. What do you think? Someone want to shout it out? This is pretty simple given what we've already said today. Yeah. A star BA. Yeah, this is very similar to that little example that we were talking about before. You can just change the n into a star. In this example, that's not always going to work out, but in this case, it does. All right. How about, let's immediately make it a little more interesting. How about A to the n BA where n is greater than or equal to 2? So that means you must have at least 2 A's at the beginning, and then possibly more, but it has to be at least 2. To write this as a regular expression, you're only allowed to use the star or the plus and parentheses. Any ideas? There is a cute little trick, which may be non-obvious, but once you see it, it's not so hard to do. You got an idea?
Could you just do like 2 A's at the beginning and just do A star B?
Uh-huh. Yeah, A star BA. All right? So when you see this, this means you got to do at least 2. You must do 2 and then maybe some more. All right? So that's how you make it so that the number is, at least 2 or whatever. Okay, great. How about at most 2? What about that? A to the n BA where n is less than or equal to 2. There is similarly a cute little trick for doing this, although it doesn't, it looks quite different. But anybody can even think of how you might affect that? You can have up to 2, but no more than that. Got an idea?
Is it like A plus AA in parentheses then BA?
I like that. Actually, I'm going to add one little thing to that. Yes, in parentheses, the idea is if it has to be less than 2, less than or equal to 2, well, that means it's either 1 or it's 2. And so you just put that in here. You either get 1A or you get 2 A's followed by BA. Actually, I left a little blank spot here. There's actually one other alternative. What do you think? What should it be?
Epsilon.
Yeah, the empty string, the epsilon. Right. That is because the n in the original set over here, this n is allowed to be 0, and so you should put the empty string over here. All right, great. Okay, let's try a little more. How about any x in AB star such that x ends with B? Can anyone write that as a regular expression? You can have anything you like with a B at the end. Yeah?
Like A plus B in parentheses, star, B.
Yeah, great. A plus B star. The A plus B star makes whatever you want, but then it has to have a B on the end. Yeah, excellent. How about, this is a simple variation. How about x starts with A and ends with BA? Can anyone say that? It's very similar. Maybe someone I haven't heard from. Starts with A, ends with BA. Yes.
Would be A and then parentheses A plus B star then B.
Yeah, great. A plus B star, BA. Excellent. I hope that these seem kind of cute to me. In my opinion, actually, these things are, at least on its surface, to me, a lot easier than making a DFA or an NFA for these languages. I don't know. It just seems to me to make a DFA to accept this is, I mean, it's not too hard, but I'd have to spend a few moments thinking about it. Whereas this, to me, is very, very clear how to write a regular expression for that same thing. Okay, what about, okay, how about x such that x contains BA somewhere? Not necessarily at the beginning, but it could be at the beginning or the end or whatever. Contains BA somewhere. Anybody got an idea for that? Uh-oh. I just touched the wire. Oh, it's okay. Any thoughts? Contains BA? Yeah, what do you think?
Could you do like parentheses A plus B star and then BA and then another B star?
Yeah, I like that. So that means anything at the beginning, then it's got to have a BA in the middle somewhere, and then anything else afterwards. All right, where the anythings can be empty strings. So the BA could be at the beginning if you want, or it could be at the end. Excellent. How about, here's one inspired by, there was some homework problem about this. How about x contains 3 consecutive A's? This one actually is very similar to the previous one. It just means, another way of saying that is, it contains the string AAA somewhere. And so it's just like the previous one. A plus B star, AAA, A plus B star, right? What about non-consecutive? So let's just say x such that x contains 3 A's, but not necessarily consecutive. Any thoughts about how you could make that one? So they don't all have to be next to each other. Yeah?
Would you do 3 separate A's all surrounded by A plus B?
Mm-hmm. Yeah, this seems like sort of overkill, but I think actually this is the simplest way to do it. A plus B star, A plus B star, A plus B star, A plus B star. I like that. There's 3 A's in there, and then just some other garbage somewhere. This is what it means for the string to contain 3 A's. This is an example where actually, in my opinion, the NFA for this one is kind of nicer than that. This is a little clumsy, I guess. Although it's not very hard to understand this when you see it. Of course, there's, in the back of your mind, I hope you are beginning to wonder this question about, like, can you actually do everything with an NFA? Can you do that on a regular expression? Or can you go the other way around? Can you take any regular expression and change it into an NFA? These are questions that we will talk about eventually. Let's just do a couple more of these. Oh, we got plenty of time. How about, okay, here's another one. How about just A to the N where N is even? A to the N where N is even. What do you think? Yeah, I like that. AA star. So this is any repetitions of 2 A's at once. So you could take 0 times would give you the empty string. 1 time would give you A a squared. 2 times will give you a to the 4. Yeah, excellent. How about, what if you want it to be odd? How would I do that? It's like the same thing, but you want one more. Here's how you shouldn't do it. It's not that, because that means this will get you multiples of 3 every time you get 3 more. What is it instead? Yeah, put the a outside the parentheses. A star, like that. Yeah, this gives you sort of this part here makes it even with the star, and then one more extra makes it odd. Great. I got a few more. I'm full of them. How about... All right, how about this one? Similar, but this is any string, let's say just using A's and B's, where the length of x is even. So this has A's and B's in it, but there's a even number of stuff overall. Perhaps a variation of this, maybe? Any thoughts? What do you think? This is a good idea, although not quite. So she said this. That matches anything which has like 2 A's followed by 2 B's maybe, or 2 more A's, but this does not match something like AB. But AB is supposed to be accepted here, or it's part of the language, because the length of that is even. So this doesn't get enough stuff. Any other ideas? Yeah? Yeah, I think he said a plus b, the whole thing star. Yeah, so this on the inside has 2 letters. Each one can be a or a b. And then the outer star means you're taking these things, but they're 2 at a time. And so the whole string has to be built up of blocks of 2, which makes it even. Yeah, great. Yes?
How does that account for the empty set? Because isn't the empty set technically even?
Yes, the empty string is even length, and this whole star you can do 0 times, which means you just get nothing. Yeah?
Could you also do a plus b star and a plus b star with that number?
Like this? With a plus? Or
Not with a plus,
not
like-
with a plus, just next to each other? I don't think this works. This means this part can be anything, followed by another anything. But it doesn't make the, like this first one could be empty and then this one could be an odd number of things. Yeah. All right, great. All right, one last one, and then we'll talk about something a little. So your homework about these will be just a bunch of these. And actually in the book, for some reason, they decided to put all of these in one question. So I'll ask you to do like number 1 parts A through M or something like that. I don't know why they did that. How about this one? The number of A's is even, but it can have any number of B's. This one's a little tricky, I would say. The number of A's is even, but it also has B's in there. My suggestion would be start with this. This gets you just an even amount of A's, but you also want to allow that there could be B's in there somehow. So I'm gonna, that's not the answer, but modify that a little bit perhaps. You got an idea?
Yeah, would it be in parentheses AA plus B?
AA plus B
Yeah, with the star.
with the star. Okay, this is pretty good. The effect of that is, that you can now have B's in there every time you sort of loop through the star. You could either use AA or use a B. Actually, this is not quite good enough. Can anybody say why? I don't mean to pile on our dear friend here. Yeah.
Doesn't allow for non-consecutive days.
Yeah, right. Every A that appears here is automatically going to be next to another A, which we don't want to make that requirement. So, like in this case, there's no way to actually encounter a B in between these two A's. Can we fix that somehow? He's avoiding eye contact now. Anybody have an idea how we could repair the issue? Actually, you can. I mean, starting with this, you can kind of make some modifications in there, perhaps. The problem is using this regular expression, you're not allowed to put a B in between these two A's. Can I change it so that you would be allowed to put a B in between those two A's? Yeah.
I don't know.
Okay. Yeah? Yeah, like you can actually just put a B star in between these A's. Then it does allow you to put B's in between those A's. So we get A, B star, A plus B star. And I think that's my final answer. I believe that this can get anything where the number of A's is even. This one is not easy at all, I would say. And if you ask me, it's a lot easier to come up with the DFA or NFA for that than this regular expression. All right. I think that will do it for those examples. What I want to talk about, and I think we can at least get started talking about this, is the relationship between regular expressions versus NFA versus DFA. All right. Now we already know that NFA and DFA actually have the same capabilities in terms of what languages they can generate. That's because every DFA actually is an NFA already. It just doesn't use epsilons and whatever. And also there's a procedure to convert NFA back to DFA. And so the NFA and DFA are kind of interchangeable. You can use one to simulate the other. What about regular expressions? How does that fit into this this collection of stuff? Well, part of this I want to talk about right now, and actually I will say not too hard to convert a regular expression to NFA. So this at least is part of the answer to this question about what's the comparison between them. So you can actually convert a regular expression into an NFA, and if you want, you can make it into a DFA by converting the NFA into a DFA. Although we're not going to talk about that very much. So I want to try to describe in the remaining 15 minutes or so. We can probably do a simple example of this. How do you convert a regular expression to NFA? So let's just talk about very basic parts of a regular expression. All right. Of course, every regular expression is made up of little bits of strings like A's and B's, also pluses and stars. So if we can talk about, first of all, how would you handle just a little bit of a string by itself? How would you handle a plus of two things? And how would you handle a star? If you can understand all of that, then you can patch together a regular expression and turn it into an NFA. So the first thing to do would be to talk about, let me just say strings, plus, and star. All right. So to talk about strings, if all you see is a little bit of a string, how would you convert that into an NFA? For example, if I just see something like BAA, ba, as a regular expression, this is not very interesting because it only matches one string. It matches that string, BAA. But anyway, how would you make an NFA to only match that one string, BAA? It would look like this, right? That's an NFA which has the same effect as that regular expression. And there's nothing very interesting to say about that. But if you see a little piece of a string, it turns into an NFA that looks like that. All right. What about a plus? Now is when things get a little bit more interesting. The plus. All right. That means you somehow have like a regular expression, maybe R1 plus R2, where these are two different regular expressions being added together. And I want to make an NFA which matches the plus. Remember, the plus means or. And actually, this is something we already talked about. It came up on the homework for this past week about how to make an NFA for a or. Anybody remember the strategy for that? In a sets, this would be used when you want to make the set, the language is a union of two other languages.
You have like an epsilon going to it.
Right. You start somewhere and then you have two parallel tracks with these epsilons. Right? And so if you somehow already knew how to convert these two regular expressions into NFAs and you saw a plus, you would do it in this way. You have some sort of dummy starting state, which doesn't really do anything by itself, but it just splits off into two other sort of smaller machines. Now, for technical reasons, when we do this operation, what I'm going to do is come out of each one into a single accepting state using epsilons. The reason for this is that the idea behind this sort of stuff is, of course, you don't typically see a regular expression which only looks like this or only has a plus. It's usually some kind of complicated combination of these things together. And so it's important to be able to actually combine and like tie these together one after another. And to make that easier to do, it's a lot better to have each of these things is going to be written with a single accepting state so that it's easy to pipe this one into another one if you wanted to attach it to something else. Rather than just leaving this with the two separate hanging blocks, then it's harder to say how am I going to tie that into something else. All right, last thing is the star. And this, I said I was going to leave 10 minutes at the end to talk about the test. So the last thing is the star. How do we handle a star if I have something like R star, right? This we haven't actually talked about, but can you make a NFA which basically, I want to draw some diagram with like a block like this. And would you mind if I start in the same way? We have some kind of starting state which just goes into R. How can I make this, and then maybe I'll start it up like that. Now, as is, this thing doesn't do R star, it just does R, right? You come in, you go through R, and then if you make it through R, you get to the accepting state. Can anyone suggest a simple thing I could add on here that makes it do R star instead of R? Yeah?
The end to the beginning.
Loop the end to the beginning, yeah, with, what am I going to put on the arrow? This is a good idea. I don't want to put like an A on the arrow though, because then,
Epsilon.
yeah, you put an epsilon there. All right, that means you go through, and if you want to, for no reason, you can go back and do it again, and do it again, and do it again, and do it again. Yeah, great. Actually, there's one more technical thing that we need to add onto this. I'm going to bring this below the page break. Problem with this is the star, of course we all know the star allows for 0 repetitions, but this diagram does not. In order to get to the accepting state here, you must go through the R at least once. But I want to, can anyone suggest, can we change the diagram so that you don't even have to go through the R at all? You can, if you want to, jump all the way to the end. Yeah? This would do it. She said make the first state and accepting state also, but in the same vein as what I said before about I want to be able to tie these things together. I don't want 2 different accepting states. I want to have one accepting state at the end so that I could easily plug this onto something else. Another idea?
You shoot the epsilon in the starting state to the end state.
Yeah. Put another epsilon like this. All right, so that forwards epsilon almost never gets used. The purpose of that is only so that you could, if you want to, skip the R entirely and just go straight to the end. So these are how you can combine various regular expressions together and make an NFA out of them. Can we just try one example? And then we will talk about the test. So I hope that you, I would suggest you, remember these two basic schematics here, because that's how you're going to make these things work. So let's try make an NFA for, how about A plus B star A. I find that this is easiest if you kind of build it up little bit by little bit. So maybe first I will do what's inside the parentheses first, because these can get a little complicated. This one is not all that complicated, but let's first do A plus B. That's a plus, so it would look like this two branching paths one. And then what happens on each of the branches? Well, the one of them is a A and the other one is a B. So to get just a A, I do that. And to get just a B, I do that. And then I'm going to tie them both back together with epsilons, just so that I make a nice sort of compact block, which now can be slotted into those other types of diagrams. All right, so this right here is A plus B. Now, you might say, do I really need all of those epsilons? Actually, the answer is no, but for the sake of doing this in the structure that I'm talking about, this is the most convenient to work with. Of course, you could, if you really want to be cute about it, you could have just done that, right? That's equivalent, although usually I don't care about writing things in the most possibly efficient way. Anyway, that's A plus B. How about A plus B star? This is the next kind of the next level here. A plus B star. It's basically the same stuff, but what's the difference? Yeah? Right, I make the sort of loop of epsilons from the starting state all the way to the end, and also from the end back to the beginning. So it looks like the same stuff, but I'm going to wrap it inside of the star, which is to say I put the epsilons going in a loop. So there's a epsilon coming back and epsilon going forwards. All right, that's A plus B star. And now what I'm really looking for is A plus B star followed by A, and for that you just follow this thing by A. So would you mind if I just, you could draw it again, but it's that. All right, I just follow the whole thing by A. And now I'm done. I can indicate this last one is the final accepting state, and where I started was the starting state. So this is my answer. All right. And this same strategy of building up little blocks and sticking them together, you can do this to make an NFA out of any regular expression. Even a very complicated one will turn into a big complicated diagram. All right. So I think we'll do some more examples of this when we come back, I guess, I don't know, a long time from now when we have our next regular class. But we'll do some more examples of these. All right. I think that'll do for what I wanted to say. So I don't have a whole lot to tell you about the test. I had just sort of like a little list of topics. And then in our remaining few moments, I'm happy to discuss any of these things. But anyway, our test is on Friday, a week from today. That's the 23rd, I think. So I sort of went through, I mean, basically everything is fair game for what's going to be on the test. So I would say basics about languages, just sort of terminology and such. You should know like what I mean by alphabet and language and so on. And then the first kind of technical stuff we talked about is DFAs. So you should know if I describe to you a language, you should be able to make a DFA for that. If I show you a DFA, you should be able to tell me what the language is for that. So that's sort of basics of drawing them and telling what the language of the machine is. And then we also had the formal description. I hope you remember how, this is not hard, but you have to remember just how to write out the various ingredients of a DFA. If I show the picture, I might say, tell me the formal description of this DFA, which involves writing a lot of stuff with the little deltas. And then it could be the other way around. I could tell you the formal description and have you draw the picture of the DFA. And then we also talked about the product construction. This is the only sort of construction of DFAs that we talked about, I think. The product construction, this is for making unions and intersections of DFAs. What I mean, of course, is the unions of the languages. You could make a DFA whose language is the union of the language of the two other DFAs, or intersections. All right. And then related to this, you should know, not much, but you should know what I mean if I say regular language. A regular language is one which can be the language of some DFA, and equivalently can be the language of some NFA because they are the same. All right, I think that's about it in terms of what you should know about DFAs. For NFAs, it's all the same stuff basically. I could show you a language and ask you to make me an NFA for that language, or show you an NFA and ask you what's the language of this NFA, etc. There's a formal description for NFAs. And then you should also know the subset construction. This is what you did on the quiz today. This converts NFA converted into a DFA. All right. And then there was regular expressions. And for this, I will ask you to sort of just make me a regular expression for this or that language, similar to the examples that we were doing 20 minutes ago. Make a regex for some language, or tell the language of a regular expression. If I show you a regular expression, I can ask you describe the language of strings that this regular expression matches. And let's leave it at that. So I won't ask you to do this regular expression convert to an NFA thing. And for, I know we haven't spent a lot of time on this, but you will have homework problems on this topic. Anybody we got 5 or 6 more minutes on the clock. Anyone want to chat about any of these things? We could do an old example of something or other if you want. Or not. There is one person remaining who hasn't told me about their grade percentages. I'm not going to call you out publicly, but send me an email later on today, or tell me in person on your way out, and I will type it into my grade book. It seems like everybody's satisfied. If anybody does want to chat about any of this, I'll be here for the next 5 minutes. Otherwise, have a nice little time off from this class, I suppose.